Hello, on this video, I'm going to just throw out a couple of questions for you, and I would really like to get you guys' input on how do you have your students graph in the different forms of linear equations. So, of course, if you're graphing in slope-intercept, I think that's usually the easiest and the most self-explanatory, that they can find what the slope is and what the y-intercept is on that one. So we'll kind of skip over that because I think that is easier. But the next one I do want to talk just a little bit about, because I have seen teachers who are very rigid, I would say, and that you have to always change to slope-intercept. 100% of the time, everything goes to slope-intercept. And I guess that's okay because you're doing one method all the time. But my question is, how many of you also teach to do the intercepts? So here is my logic, and I tell my kids this when we're doing that. I am fine with going to everything in slope-intercept. I am fine if you want to find the intercepts. But here is where I think that piece of finding the intercept comes in to play the most, and that is when you actually start getting into your application problems, your story problems, that kind of thing, in which you are maybe you're doing a problem with solutions. So I guess the problems I'm thinking about are the linear programming problems, maybe, where you're doing inequalities, where if you put it in slope-intercept, sometimes those values don't make any sense and it becomes very hard to graph. Like maybe your intercept is in the hundreds, tens or hundreds, but your slope is like a point something. So that is where I think it becomes an issue. So I like to show my kids or tell my kids, if it is in slope-intercept form, great. Find your slope, find your intercept, great. Graph it. But if it is in standard form, then just find your intercepts. And so that's kind of the logic that I give my kids. So if it is in standard form, I don't want them to change it to slope-intercept form. And I know in the textbooks, you'll have a whole page that it's like change to slope-intercept, change to slope-intercept. And I guess I just don't see the purpose for it. And so I'd kind of like your feedback. What do you do? How do you teach your kids? Are you one that wants everything to go to slope-intercept, or do you also teach just finding the intercepts? Do you give your kids the option? They can go either way. What do you do? Give me some feedback on that. The next thing is point-slope form. Again, I'm going to ask you the same question. If you're working in point-slope form, and here's the other thing, I have always tried to figure out why, and those of you who are in geometry or geometry teachers can probably relate to this a little bit. But, in geometry, they start teaching point-slope form. But rarely ever, if any, do you see point-slope form in Algebra 1. I personally, over the last probably 5 or 6 years of my teaching, like I said, I've been teaching 35 years. So we're talking a lot of years that I didn't do this. But over the last 5 or 6 years, I started using point-slope form a lot in Algebra 1. And I found that, especially my low kids, they could make sense of that. If they were trying to do, and we'll talk a little bit about this in a little bit, but if they were trying to write equations in slope-intercept, they kept forgetting to put the numbers back in. Take that b, they would find it, and they're like, oh, wow, I solved the equation, b equals 3. But they would forget they still had to write their equation. I'll go back to that in a little bit. But here's my question to you on this one. If it is in point-slope form, or if you are writing an equation, do you have them change it all the time to slope-intercept form? Or do you have them change it all the time to standard form? And, or are you okay with it just being left in point-slope form? Okay, so we're going to talk about graphing or writing equations in a little bit. But I guess my question, like I said, the main question is, if you're graphing it, because we're talking about graphing here, if you're graphing, so let's think about that. How do you make them graph it if it is in point-slope form? Do you show them how to identify the 2 points and the slope and then straight go to the graph? Or do you make them change it to one of the other forms? So that is my question to you. Okay, so the next thing I want to talk just a little bit about is writing linear equations. What happens if you're given these different things? So obviously if you're given slope and the y-intercept, slope-intercept is the easiest form to go into. If you're given a line parallel to and the y-intercept, definitely the easiest form, and so forth, line perpendicular. So I'm not going to question these at all. I think slope-intercept is the best form to go into. But I want to go back in a little bit more and talk about point slope form, because as I said in my last 5 or 6 years of teaching, point slope form actually kind of become my favorite form. And I tell the kids that. I said, you know, you got 3 forms here, and they look at me like I'm a nerd, you know, that I have a favorite form. But I really have got to the point that I like the point slope form. And so again, that's kind of where I teach a lot. And actually, I like when I'm doing slope right off the bat to show them how you can change slope into point slope form. Okay. And so this is when I use the point slope form. If I'm given the slope and a point, I'm just going to plug it right into here. If you're given 2 points, okay, and I have kids who really like this. Matter of fact, I have kids when they're doing slope, they will do it, their slope now in this form. 2 points, put in your X's, you know, make sure they match up. We did a discussion about talking about that, but we've done that with slope already. And just put your 2 points in there. They solve for M, and then they'll go back to their equation and take out 1 set of points and put their slope in. So again, it's kind of like that y-intercept, but like I said, I have kids who really like to do it that way. Same way, if you have the line parallel to and a point, how easy is it to put your equation here for your slope here, go ahead and just put your point there. And why, if I'm wanting to graph in particular, do I need to change forms? Because there's my points, there's my slope, I can go straight to my graph. Okay? Line perpendicular to and a point, again, same thing. Put your points in, put your slope in, voila, you've got it. You can go straight to your graph. Now, I'm not saying that there is not definitely 100%. There is justification for always going to slope intercept, justification for always going to standard, whatever. But I'm just saying, you know, if you have not tried it, if you have not tried using point slope in Algebra 1, try it. Give it a go. See how the kids react to it, and maybe you'll have some who like it. If you're in a class that could have some very low kids and so forth, check it with them. See if they like that, because like I said, that is probably some of the ones that I have found that like it. But I've got some of my really top kids who just love this form. It's one form. They can use it for everything. They don't have to do a lot of different forms. Okay? So again, those are my questions to you. So do some discussion on it. Give me some input. Maybe you're very, very pro one way and con the other. I want to know. It's open to discussion. Okay, so after I made the video, I got to thinking about something else, and I thought I'm going to make a quick plug again for Desmos. And again, if you're like me, graphing so many different papers is difficult, and maybe getting around to all the different kids is difficult. So if you're doing any of the things that we were just talking about, I would definitely have kids check their own paper on Desmos. And again, example, let's say they're doing y equals 3x plus 2, and they're needing to change that. The thing is, change it to standard form, or they've already given standard form and they need to change it to slope intercept, either one. So what I have them do then is put both of them into their computer and then look to see if in fact they got the same line. So, okay, yes, it's the same line, it's not the wrong line. So let's say they messed up and they didn't change a sign. Then they can say, okay, definitely, it's not right. Then you say to them, okay, you've got to figure out what's wrong. Well, hopefully, if the kids are doing, what they're supposed to be doing, the first thing they should be able to say is, well, my slope of the second one is wrong, so somewhere in my slope, I messed up. And so then they can come back up and re-look at that. But again, it is them figuring out what they did wrong. And it doesn't matter even if you're writing your equations. If let's say you're writing your equation through 2 points, or well, let's say they were given a slope of 2 and a y-intercept of 3. Y equals 2x plus 3. Great. And so then you tell them, okay, now you need to go to your graph. Does it have a y-intercept of 3? Yes, it does. Does it have a slope of 2? Well, they're going to have to do a little bit of calculating. They'll say, okay, well, that's 1.5 over 3, or 3 over 1.5, I should say, or 1.5 over 3. My brain's fried. Or here's a 1. So they can look at it. And yeah, it does have a slope of 2. Okay. Same thing if they're going through 2 points. You could look and say, okay, did it hit those 2 points? And even if it's not on their line, see, they can hit anywhere on there and check it. So use Desmos. Use it as a checking tool. Like I said, it's fun. It's awesome. The kids enjoy it. They can check themselves. They can figure out what they did wrong. And I am a big component, or a big believer, if you want to say, in having the kids figure out on their own what they did wrong. Okay, and having them fix it. And they could even put out to the side, this is what I did wrong. Here's the correct answer, and this is what I did wrong. A justification. Okay, so use Desmos, guys, as a grading tool.